Now continuing with the electrolysis, actually I have to stop there because the current went off and hence I am going to continue from there itself. So continuing with electrolysis, so I was saying you that is you will take an electrolyte and this is the anode and this is a cathode. Why it is called anode? Because connected to positive terminal of the battery. Why it is called cathode? Because connected to negative terminal of the battery. When you will pass electricity through this electrolyte, which is in the aqueous solution state or in the molten state, which is known as also fused state, then you will find that the electrolyte dissociates into its ions. Got it? It dissociates into its ions. And when it dissociates into its ions, you will be having two types of ions. One is your cations, another is your anions. So cations is, what you can say is that it's nothing but positively charged and anions is negatively charged. So cations will go to the cathode, it will migrate toward the cathode and it will get deposited here. Anions, which is negatively charged, it will migrate towards the anode and it's going to get deposited here. So remember it, cations is positive, so it goes to the cathode, anions is negative, it goes to anode. Alright, in this way the electrolytic process is being completed. We can say that. This is known as, basically this is known as electrolysis. Alright, I think you got an idea. Now the question comes here, how do we know that a given substance, which is substance which is given to you in the molten state or any substance in the molten state or in the aqueous solution state, will it conduct electricity? No. No. Any substance in the molten or aqueous solution state, it is not necessary that is going to conduct electricity. Because electrolytes, what you find is that are those substances which allows only electric current to flow through it. Alright? And thus it dissociates into its ions. But there are certain substances which in the aqueous solution state or in the molten state does not allow electric current to flow through it and hence it does not dissociate into its ions. So those substances are known as non-electrolytes. They are called as non-electrolytes. In the aqueous solution state, you take the substance in the aqueous solution state or you take the substance in the fused state or in the molten state, you will find that it does not dissociate into its ions even if you pass electric current through it. They are known as non-electrolytes. Why? Because in non-electrolytes only molecules are being present. Alright, when you dissolve it in water, alright, when you put into water that particular substance or when you take the substance in a molten state, what happens? What does it happens that it does not conduct electricity? Because their ions are not present. Remember it, ions are responsible for what you can say conducting electricity in case of electrolytes. Ions are responsible, this cations and anions, these are responsible. As the electrolyte dissociates into its ions, these ions are responsible. But in case of non-electrolytes, these ions are not present. Then what is being present? Molecules are present. That means when you pass electric current through it, it does not dissociate into its ions. Then what happens? Molecules are present. And remember it, molecules never conduct electricity because they are neutral in nature. We can say that. Clear? For example, distilled water is a non-electrolyte. For example, alcohol, kerosene, any gas, oxygen, nitrogen, inert gas, carbon disulfide, liquid carbon tetrachloride, they are said to be as non-electrolytes. Similarly, electrolytes are dilute acids like dilute HCl, mineral acids, dilute HCl, dilute HNO3, dilute H2SO4, then bases like aqueous NaOH, aqueous KOH, we can say that. Clear? And electrolyte like what you can say, even you can take aqueous copper sulfate solution also, we can take that. You can also take, that is acidulated water, it's an electrolyte, acidulated water. I said you distilled water is a non-electrolyte, but acidulated water is an electrolyte. What do you mean by acidulated water? You'll take water and you'll add few ml of the sulfuric acid into it, concentrated sulfuric acid into it, which is also otherwise known as dilute sulfuric acid. Remember it, dilute sulfuric acid and acidulated water both are same. The meaning is same. Apply the common sense. Acidulated water means acid is added to the water, hence it becomes acidified or acidulated. Same thing, dilute sulfuric acid. How do you prepare dilute sulfuric acid in the lab? You take water and you add concentrated sulfuric acid into it. Isn't it? For example, we take 1 liter of water and we add 125 cc of dilute sulfuric acid into it. Alright, so you will be getting the dilute sulfuric acid in this way. So dilute sulfuric acid and acidulated water both are same. So that is an electrolyte. Pure water is not an electrolyte. Pure water in distilled water is not an electrolyte, because pure water, it consists of molecules only, it does not consist of ions. Similarly, that is salts in the molten state, like lead bromide, molten lead bromide, you can say that it acts as an electrolyte. Got it? Copper sulfate aqueous, just now I was saying you, aqueous copper sulfate acts as an electrolyte. So they are electrolytes. So how do we know that it's an electrolyte? How do we know? Alright, how do we know that this substance is an electrolyte, this is not a non-electrolyte? Under electrolyte also we are having strong electrolyte and weak electrolyte. Strong electrolyte means which dissociates almost completely into its ions. Which dissociates almost completely into its ions. This is called a strong electrolyte. Means, what does it mean? See here, for example, what I said is that, suppose if you take, let us say, dilute sulfuric acid. Let us say dilute sulfuric acid, H2SO4. Got it? When you pass electric current through it, it dissociates into 2H plus and SO4 2 minus. And dilute means water must be there. Got it? Dilute. So water has to be there, otherwise how it will be dilute. So hence H plus and OH minus, it will dissociate. What will dissociate into H plus and OH minus? And sulfuric acid will dissociate into H plus and SO4 2 minus. This is known as dilute sulfuric acid, or I said it just now to you, acidulated water or acidified water. Got it? Clear? So it is a strong electrolyte. Why do we say strong electrolyte? Because let us say I am taking 100 molecules of sulfuric acid. It dissociates almost completely. Let us say 99 molecules dissociates. So in case of strong electrolyte, the degree of dissociation is calculated with the help of alpha. Alpha is the degree of dissociation. How do you calculate alpha? Number of molecules dissociated by total number of molecules. By total number of molecules. I don't have the space here, otherwise I can write it here, of course. But the diagram is coming in between. So see here, understand it. Number of molecules dissociated by total number of molecules. Let us say total number is 100. Let us say. And number of molecules dissociated is, let us say 98 or 99 or 95, anything. Alright, so then the degree of dissociation will be how much? It is always calculated in terms of percentage into 100%. It is always calculated in terms of percentage into 100%. Alright, let me rub it this time, that will be better. Otherwise, it is overlapping these things. So, what I said, number of molecules dissociated by total number of molecules. Total number of molecules, we can say into 100%. Number of molecules dissociated by total number of molecules into 100%, we can say that. So in this way we get the degree of dissociation. I was talking to you, let us say total number is 100 and number of molecules dissociated, let us say 95 or 96 or something like that. So degree of dissociation will be 96% around, we can say that. So anything above 30%, if the degree of dissociation is greater than 30%, then it is considered to be a strong electrolyte. Remember it. If the degree of dissociation, if the value of alpha is greater than 30%, then it is considered to be a strong electrolyte. If it is less than 30%, it is considered to be as weak electrolyte. And if the degree of dissociation is almost nil, zero, we can say that. Hardly 1 or 2% dissociates, then it's said to be as non-electrolyte, that's said to be as. Alright, again I repeat, if the degree of dissociation is greater than 30%, it's said to be a strong electrolyte. If it is less than 30%, let us say it's a weak electrolyte. And if the degree of dissociation is almost nil, zero, then it's considered to be as non-electrolyte. Alright, clear? In this way, we calculate the value of alpha and we find it out. Whether it is strong, weak or non-electrolyte. This is theoretically, we find it out. Theoretically. Now, practically, how will you know? First, we need to do the practical, isn't it? Practically, how do we know? Suppose a substance I have given to you, and how will you know? It is also colorless like water. Alright, how do we know that it's a strong electrolyte or weak or non-electrolyte? Now, see here, the same experiment. For that reason, I did not rub that particular diagram, but I have to rub it because I need to tell you the formula. For that reason, I rubbed it. So here, I have taken an electrolytic tank, I have taken it, or an electrolytic vessel, I have taken it, and this is connected to a battery. Let me rub this also. Yeah, this is connected to a battery. You can see that it is connected, negative, positive terminal, and in between, I will be taking a bulb here. I will be connecting a bulb in between. This is a bulb, I have connected it. In between I have connected a bulb, let us say. Okay. So now this is your positive terminal of the this is a positive electrode, this is a negative electrode in this way. Now you have taken an electrolyte here. You don't know this electrolyte is strong electrolyte or a weak electrolyte or a non-electrolyte. You don't know. So the glowing of the bulb will indicate. Now listen carefully. You will be having a switch here. A switch will be here. A switch will be present here. You take an electrolyte. You set it up in this way. You put a bulb here. You put a switch here. When you switch it on, listen carefully. When you switch it on, and if the bulb glows brightly, then it's a strong electrolyte. If the bulb glows brightly, it is a strong electrolyte. Then it is a strong electrolyte. If the bulb glows dimly, you know that's little bit it glows, then it's a weak electrolyte. And if the bulb does not glow at all, it does not glow at all, it is a non-electrolyte. We can say that. So in this way we find it out. Of course, I will be putting a just to make it this. See, this is a bulb. We can say that. So if the bulb is glowing brightly, it's a strong electrolyte. If the bulb is glowing dimly, it's a weak electrolyte. If the bulb does not glow at all, it's a non-electrolyte. In this way, we find it out experimentally whether it's a strong, weak, or non-electrolyte. What you need to do is that just to change the electrolyte here. Suppose you take distilled water, then you take sulfuric acid, then you take aqueous copper sulfate, then you take molten lead bromide, then you take alcohol, then you take kerosene. In this way, you go on changing the electrolyte and you observe it, what it happens. It will give you whether it's strong, weak, or non-electrolyte. In this way, we classify it whether it's strong, weak, or non-electrolyte. Is it clear? And I've said it theoretically also how to find it out whether it's a strong, weak, or non-electrolyte. I told you theoretically. If it dissociates almost completely into its ions, suppose a particular electrolyte I've taken it and almost it dissociates completely. Suppose 100 molecules I've taken and nearly 100 molecules dissociate, then it's said to be a strong electrolyte. And only very few molecules dissociate, let us say 10 or 20 molecules dissociate, then it's a weak electrolyte. That means in case of strong electrolyte, only ions will be present. Remember it, in case of strong electrolyte, only ions will be present in the solution. And in case of what you can say weak electrolyte, like NH4OH is a weak electrolyte, ammonium hydroxide is a weak electrolyte. It will dissociate to give you NH4 plus OH minus. If you take around 100 molecules and around 15 or 20 molecules will dissociate. 15 or 20. So here you will be having molecules, undissociated molecules, and here you will be having ions. So if in the solution, if in the electrolyte, undissociated molecules and ions coexist together, then it's said to be as a weak electrolyte. And if only molecules is present, it is non-electrolyte. And if only ions are present, for example, I wrote it in the previous H2SO4, you can say that only ions are present. Or suppose you take here fused NaCl, fused means molten. It dissociates to give you Na plus Cl minus. So if you take 100 molecules, you will see around 99 molecules will dissociate. So only what you will get? Ions are only being present. So to say, one molecule, that is negligible. So ions are only present. So if in a particular solution, if ions are only present on passing electric current through it, that is a strong electrolyte. And if there is undissociated molecules and ions which are present in equilibrium, this is an equilibrium sign, you know that, then it's said to be as weak electrolyte. And if only molecules are present, it does not dissociate at all, then it's said to be as non-electrolyte. In this way, we determine whether it's a strong electrolyte, weak electrolyte, and non-electrolyte. I hope you understood it. Thank you.